button quickly and let you know that this meetup is being recorded and will be available in about a week on our YouTube page. And we will send you an email with a link to that when it is ready. You can also find the other meetups that we've had on that page as well. We've recorded most of them, so you can check that out if you want to get a quick look back into our short history. Thank you for coming. I feel like I haven't done this in a while because I didn't host the last one, but I'm glad to be back and I'm glad to see you guys here. And I'm really excited about the one we've got today because a coworker of mine and a good friend of mine is giving it. And it's a really interesting topic. So I'm excited to see it here and to be able to bring it to you guys. And I'm not going to take any more time away from him. So Jason, why don't you introduce yourself and then you can go ahead and get started.
All right, sounds good. So thanks for the introduction, Johan. Today I'm going to be talking to you guys about running Kubernetes and Kubernetes. It's kind of an interesting concept and pretty cool. Really excited to present it to you guys today. I presented it yesterday at CBIT, where in an audience of about 50 people, 4 of them had even heard of Kubernetes before. So it was a bit of a challenge to present some of the concepts, but I'm really looking forward to presenting it to you guys, and hopefully we'll be able to get a little bit deeper into what running Kubernetes and Kubernetes actually means and some of the challenges that are presented by Kubernetes and how to overcome some of those challenges. So to start off with, I need to get my slides to work here. All right. There we go. So who am I? My name is Jason Murray. I'm Canadian and I live in Hamburg, working at Loodse. So my handle is k8sOM. I love working with Kubernetes, love sharing the platform and helping with adoption wherever I can. I've been working with Kubernetes for just over 2 years. Got involved in the project pretty early and never looked back. Really love the technology and love the direction of the project and the community. So I work at Loodse, developing a product called Kubermatic, and also working with some of our customers to learn how to utilize Kubernetes and leverage the power that comes within. So I can probably skip most of these slides. I'm just watching chat here. Is there anyone that is watching today that isn't very familiar with Kubernetes or is kind of new to the community? If you could just kind of blast a message in there. Otherwise, I'll pass over these slides for now and move on to some of the more deep topics. So not seeing anything in the chat, so I'll just go ahead and hop past these here. We kind of know what Kubernetes is already. So container orchestration platform abstracts away from the infrastructure. It helps us manage and deploy applications easily and consistently, and helps us manage safe and controlled updates and changes to the applications. We know what containers are, and they help us abstract away from, or they're an abstraction for allowing us to package applications, giving us consistent deployments, and it helps us adhere to the 12-factor principles that kind of came out of the Heroku guys a while back. If you're not familiar with 12-factor, I really recommend anybody working with Kubernetes, container orchestration, or development, definitely take a look, 12factor.net. It's a really good resource, and really kind of codifies how to think about designing your applications and how to deploy your applications. So the first question that comes to mind when we talk about running Kubernetes and Kubernetes is why. So one of the big things about Kubernetes, so Kubernetes itself is great, and it allows us to really kind of take a much deeper look at this pets versus cattle semantic and kind of get an idea of, how to move away from treating our applications and treating the dependencies of our applications like pets, and really start to treat them like cattle, where we can just take them out back, shoot them if they're not healthy, and kind of replace them. The interesting thing about this whole semantic is that, well, our applications stop being the pets, the clusters kind of become the pets themselves, and that negates a lot of the gains that we achieve by abstracting away from the application, and really by using these core abstractions to get away from the application itself. Now all of a sudden the pet becomes a cluster, or clusters in most cases, and that negates any gains we got. So how do we get past that? So Kubernetes allows us to define our infrastructure as code, allowing for simple management of the application. You can clearly define dependencies, namespace policies, etc. Those things are all great, right? So why do we run Kubernetes and Kubernetes? Well, because it gives us all the advantages that we get from applications now for our clusters as well. We get the native multi-tenant stuff. We get safe cluster changes and updates. We get the reliability and durability that we usually associate with running an application in Kubernetes. Well, the reality is your cluster is really just the same thing as any other application you would deploy into Kubernetes. It really gives us kind of all of the watchdog effects that you're looking for from Kubernetes running an application for your cluster as well, or clusters in most cases. And you have no OS or cloud provider binding. You can easily test configurations. Standing up clusters becomes just a matter of pushing a new deployment into your seed cluster or your initial cluster, and away you go. You can run as many Kubernetes clusters as you need. And when the need arises for having a Kubernetes cluster for a specific purpose, maybe you just need to test out a little feature, maybe you just need to see how some kind of database is going to interact with Kubernetes, you can just stand up a cluster, test it, throw away that cluster when you're done. You don't have to worry about damaging any of your other clusters. You don't have to worry about getting some negative interactions from your other clusters, and you're really, really safe in how you run those things. So some of the problems that come into play with running Kubernetes and Kubernetes, and this is where I'll go kind of deep. So networking is really hard. Just in general, when you start to consider things like network segmentation, managing traffic for not only your master cluster, but also for all of the client clusters that live inside your master cluster, and especially routing that, gets pretty difficult pretty quickly. You tend to have a lot of traffic that's going through not only to your master API server, but also to your client API servers. That all needs to be routed efficiently. And you have to kind of pay attention to what happens when you destroy a cluster and when you build up new clusters, so that you don't negatively impact other clusters running within this master seed cluster. So storage, especially storage for etcd. So in our client clusters, we leave that up to the client to determine how they want to manage persistent storage. But we manage in our application called Kubermatic all of the master components, which includes etcd. The difficulty with etcd is, unlike all of the other components, it does require some persistent storage to be available. And we run these master seed clusters across a good number of different environments and landscapes. So we currently, that I can think of, are running our solution on GKE, AWS. We have a couple bare metal deployments, and we also have an air-gapped bare metal deployment as well. And each of those comes with their own unique challenges when it comes to data. The big advantage is that Kubernetes recently released the storage class. And so we're utilizing that to dynamically provision volumes as you're creating and destroying clusters, which helps to make things much easier than they used to be, where we had to have code to manage provisioning volumes and actually creating and mounting all of these things wherever they needed to be. Another big challenge that we had to face was etcd. So etcd, it expects traffic to come into it. We do authentication using client certificates. And this means you can't do TLS offloading at the point of ingress, which is usually also the point that handles SNI for routing. Where that became a problem is that if you're only running one cluster, that's fine. You can start pushing things to a single IP where etcd is exposed on. Not the greatest solution, though, if you want to run multiple etcd clusters. The advantage is that all etcd requests have SNI headers on them. And so what we ended up doing was creating a thing called k8sNIF, which is just Kubernetes SNI fast forward. And that handles all of our SNI routing, but it doesn't do any TLS offloading. All it does is look at the SNI headers to see where the traffic should be routed to, looks at the cluster configuration to find out via an ingress spec where it should route that traffic to, and then forward that on to the appropriate API server or onto the appropriate etcd. The Kubernetes assumptions. So we've had a lot of difficulties into introducing different cloud providers under our particular model. Kubernetes makes a lot of assumptions about how and where you run your cluster, specifically in regards to where you run your master components and where you run your nodes. Kubernetes basically in the past has assumed that if you're running your master components in AWS, you're also running your nodes in AWS. If you're running them on GKE, your nodes are going to be on GKE. If you're running them bare metal, same kind of thing. Where that becomes a problem is that in our product, we allow you to actually go ahead and we might run our seed cluster in GKE, we might run it in AWS, but we allow you to stand up your nodes that talk to those master components literally anywhere. So you could run them on DigitalOcean, you could run them on your bare metal, you could run them on any cloud provider that supports either, I think it's Ubuntu 16.4 or Debian Jessie. Basically any Debian-based system that uses systemd, because we do leverage some systemd stuff. You can run in AWS. You can run, pretty much anywhere that you can think of that you can stand up nodes. You can attach those nodes to the Kubermatic cluster and have those up and running in almost no time at all. So we had to make several changes, unfortunately, to the Kubernetes components, which we have upstreamed into the Kubernetes project, that do allow us to abstract away from these problems with these assumptions that everything will run within the same data center or same provider, same region, same zone, etc. It took a little while for us to work around all those, but we think we've got some of the core ones out now. And as more come up, we'll definitely be addressing those as well. So the last piece is cloud provider support. So we have some pretty varying support for cloud providers in Kubernetes. It's getting better every day. Obviously, we have great support for GKE. Very good support for AWS. Justin SB and his group of guys do a phenomenal job of taking care of the AWS support. And big shout out to them. And we have varying support amongst other cloud providers as well. So DigitalOcean just started kind of getting into the game a little bit. And it's really good to see them kind of jump onto the community and start playing around. We've seen a lot of developments lately with Azure and their cloud support as well. A lot of that is being driven by Brendan Burns, who used to be part of Google. And that's definitely helping us out as we start to expand to different cloud providers and letting you run your nodes literally wherever you want to run them. The difficulty with this is that we have certain requirements when you're configuring a Kubernetes cluster to run in those cloud providers to allow you to leverage things like the elastic block storage in AWS, for example, or maybe the elastic load balancers. Typically, the biggest issues come into play with networking, load balancing, and storage. So our big challenge was that we wanted to create a very consistent plane that when you deal with a Kubermatic cluster, regardless of which provider you're running your nodes on, that you have the same expectation every single time, and you can deploy your cluster in exactly the same way every single time across all of these providers. So we had to abstract a lot of that away to create that consistent plane, independent of the host and independent of the provider that you're sitting behind. So I'm gonna hop into a quick demo here and show you guys Kubermatic and what that looks like. So just pop this guy open here. So I'm logged out right now. This is what it looks like. If you guys want to check it out or play around, in my opinion, by far the easiest way to stand up a Kubernetes cluster to start playing around with, just hit up beta.kubermatic.io and we'll be happy to have you check it out. If you have any feedback, we'd love to hear from you. So that's why I got that button right there. So I'll just go ahead and log in here. And I'm going to log in using my GitHub credentials. So magic is happening. And we'll go ahead and create a Kubernetes cluster here. So we'll stand this up in, actually I'll go US Central because why not? I haven't tested that one, so we'll hopefully break some things and I get to show you some cool debugging. So there we go. I've created a cluster. It's going ahead and starting up all of the master components that are required to run a Kubernetes cluster. I'll go ahead and download this kubeconfig here so that we can actually interact with the cluster shortly. And we're just going to wait here for these health checks to come up and say that everything's happy and running. By the way, I did forget to mention, if you guys have any questions, just hit up that link at the top there, and you can go ahead and mash your questions in, and I'll address those either as they come up or later on in the presentation, or we will have a question and answer period towards the end. So, all right. And we can now see that my cluster is up and running. So we have the components here. So the API server, the controller manager, the scheduler, and etcd, all of them are available. We run everything high availability behind the scenes. So you don't have to worry about any of that. You have a multi-node cluster of etcd, and then we run 2 of each for the API server, the controller manager, and the scheduler, just to make sure that those components are always available for you. And the big advantage is we also have health checks on all those. We have readiness checks on all those. So Kubernetes is just kind of doing its thing in the background, making sure that, if one of these goes unhealthy, if one of these goes down, it will get recreated, and it will not send traffic to anything that isn't ready to actually accept that. So big advantage of running Kubernetes and Kubernetes is it manages all of the things that we expect with regular applications as well.
Jason?
So
just a quick, we're kind of having to squint here. Can you give it a bit of a zoom?
I have absolutely no idea how to do that. Is that any better?
Yes.
Okay, perfect. Oh, you know what? Here, let me, am I sharing the whole screen or just that window?
You're sharing the whole screen.
Ah, well, that's not very helpful. Let me just, I'll just share that window a little bit easier on your guys' eyes. If I can figure out how to make Zoom do that. Uh, nope. Okay. Interestingly, Zoom is connecting to sharing my screen currently. So I'm not quite sure what's going on there.
I mean, this looks
Anyways,
alright.
I'll just move on for now.
Yeah.
So once you have your cluster up and running, the next step is to download the kubeconfig, which we already did, and then select a cloud provider. So you've got to figure out where you want to run your nodes. On our beta cluster, we're offering 3 different options. So the first is AWS, and we support, as you can see, pretty much every region that is available out there. We also have DigitalOcean and most of their regions, and you can bring your own as well. Bring your own is pretty cool because you can either use nodes that you have kicking around maybe in your lab or whatever, but also you can utilize other cloud providers that we haven't implemented as of yet. So, and we are adding more very consistently and working with different partners to go ahead and enable that for you guys as well. So we'll use DigitalOcean, and I think I created US Central. So we'll go ahead and stand up some nodes. We'll actually go with New York, and we'll copy this super secret, awesome API token, and pick my SSH key, and away we go. So we now are ready to go ahead and add some nodes to the cluster. And since this is on the company account and I don't have to pay for it, we'll throw up 3 decent sized nodes here. And so now behind the scenes, we're talking to the cloud provider using your credentials and getting everything all set up for you, deploying those nodes, getting them configured, and making sure that Kubernetes and the kubelet is up and running on them. So we'll just go ahead and wait for those to become ready. While we're doing that, I'll just go ahead and grab, oh boy, no idea how to get to this other screen. Oh, I think, there we go. Ah, much better. So you'll share this desktop. Perfect. And so we'll just wait for those nodes to come up here, and we can see them starting to come up, and they'll register with the API server and get ready to go. And then we can go ahead and hop over to this terminal here. Can you guys see that? I'll make it a little bit bigger. There we go.
Yeah, no, that looks good.
Okay, so we'll just do a get pods here. And we'll use that kubeconfig that we just downloaded. And here, we'll make that a little bigger. Oh, that's a little bit too big. Perfect. All right, so there you go. You can see that we have components running. Everything's starting to create within the cluster. And awesome. So everything's starting to come up and behave as expected. Oh, wrong cluster. So we can see that those 3 nodes from DigitalOcean have now been stood up. They're all attached. They're already good to work. And we can add and remove those dynamically as needed. We are working on features to dynamically do node scaling as well. There are a couple of Kubernetes projects that do support some node auto scaling. We hope to work with those guys to kind of incorporate that in and maybe add some additional cloud providers in as well. So you can see, I mean, we really have a Kubernetes cluster ready to go. And if I want to create another cluster, it's just a matter of seconds to create that cluster, wait for it to become ready, and then you're off to the races here. So we'll just hop over to this Kubernetes cluster. Let's say we deployed an application into it, tested it, everything was good. We don't need this anymore. We can go ahead and throw it away. And away we go. So now that's going ahead, we can see that this is actually deleting, and that'll go away. And then if we want to provision another cluster, I mean, you can go ahead and do that right away. You can have as many clusters as you want running at any given point in time. So yeah, definitely something that I would strongly suggest you guys check out and play around with. So just see some questions here from Ovi. Do all nodes have only public IPs, or can you also configure some kind of NAT IPs? So that really depends on how you are operating your nodes. Depending on the cloud provider, whether we provision them or whether you provision them, also depending on what kind of situation they're running in. So we don't have any requirements that a node has a public IP. For some of the Kubernetes functionality, specifically off the top of my head, kubectl logs, kubectl exec, and port forward, and some of the proxy stuff. There is a requirement that the API server be able to talk back to the nodes. So if you are running behind some kind of NAT, or if you're running in some kind of system where your nodes can only talk out but can't be talked into, then you are going to run into issues with running those commands. But otherwise, I mean, you run your cluster as normal. The nodes will talk to the API server, do whatever they need to do, and then carry on with life being very happy. So there isn't a requirement that you're able to talk to your nodes directly. And if you're using a NATed IP, as long as that's publicly available, then it basically becomes irrelevant as far as the system is concerned. The way that the kubelet actually, in our case, we natively, the kubelet will talk to, or sorry, the API server will talk to the kubelet using just open traffic and accepting all connections. Because that is kind of a big security risk, we actually use the same functionality as GKE. So what we actually do is establish SSH tunnels to the nodes using a key that is unique to your cluster and unique to the API server for your cluster to talk to those nodes explicitly. And we register that the SSH key as part of the installation process if you're running a bring your own node, or as part of the creation process on the cloud providers. Does that answer your question? Perfect. So yeah, if you guys have questions, I know we typically do questions mostly towards the end, but if you have questions as they come up, just feel free to mash them out into the chat, or you can also use that link that was posted earlier. And I'm happy to answer them as they come into play. That pretty much covers my demo, because I uh, because I had much more content for the other folks. So we'll just jump right into the Q&A here. So as far as updating and draining of the nodes, I'm not quite sure what you're asking there. Do you mean like updating the Kubernetes version, or are you referring to updating like using kubectl? Why can I not remember them? Cordon, uncordon, and okay, perfect. Yeah. So with the K8s version, right now there is currently no updates that are done on running clusters. That's actually the feature that we're working on. We have a hackathon this weekend, and we'll be doing dynamic updates, both of the master components and of the nodes as well. We really like GKE as a really, really good semantic for updating the nodes, where they kind of do it the same way as they do it with pods. So you stand up a new node, you make sure that that node is up and running, that it's healthy, that you can schedule things on it, and that it can talk to all of the other nodes with this new version of the kubelet. And then what we do is we tear down one of the old nodes and then just keep proceeding. So we'll bring one up, make sure it's happy and healthy, then tear down one of the old ones and bring up a new one. And so during that period of time, you will have one extra node in your cluster. As we continuously are standing up and tearing down, we're doing those checks. And then at the end of the day, you have, well, hopefully it doesn't take a whole day, depending on your cluster size. But at the end of that update process, you have nodes that are sitting there all with updated Kubernetes versions. And we will have options both for you to do that manually or to automatically do that. So that's just a setting that you'll be able to pick within the Kubermatic interface and decide whether you want us to just update as soon as we've verified a new Kubernetes version that works with the Kubermatic solution, or if you want to do that on your own at your own pace. Maybe you need an older API version for something, or you're testing with a specific API version. Then we allow you to utilize that older version. Eventually, we will, we haven't decided exactly how we want to do it, but we're probably going to allow trailing of up to 2 minor versions. So right now, if you're on 1.5, we'd allow you to run anything from 1.3 up to 1.5. Once 1.6 comes out, we'd allow you to run anything from 1.4 to 1.6, just because there are some semantics that change, and we do need to interact with the clusters to be able to manage them. So do we have any other questions? First off, did that answer the question that you were looking for, or did you have any other questions? Perfect. Instance rollout. So the question is, this instance rollout you mentioned use the underlying cloud provider service like auto-scaling groups, or did you guys roll your own solution for this? So the difficulty for us is we work on a good variety of cloud providers. So what we've done is utilize our existing code that interacts with the cloud provider. So you just updated for AWS. For AWS, we don't currently use auto-scaling groups. It is something we're looking at doing. There is some work that we want to do with how we manage and interact with the nodes and do that a little bit more closely with some of the cloud provider solutions. But right now, because we do interact with a lot of other cloud providers, including DigitalOcean and AWS and GKE, it didn't make much sense for us to do a specific implementation where we utilize auto-scaling groups that are only available on AWS, for example, or where different cloud providers use their own semantics for that. So currently, we have our own solution. Eventually, we might leverage some of the code or leverage the auto-scaling code that comes out of one of the Kubernetes contrib repositories. So Does that answer your question? Perfect. Awesome. Do we have any other questions that are out there? Or? And these don't just have to be questions specifically about the Kubermatic solution. I'm quite happy to talk about anything you guys have about Kubernetes or running Kubernetes in Kubernetes. I'm kind of a big geek when it comes to Kubernetes, so anything you guys want to ask, I'm happy to try and answer or point you in the right direction, hopefully at least.
Jason, can we get your that slide with your contact information up?
Yes, if I can figure out how to do that, I would be quite happy to.
Cool. So in the meantime, I want to thank Jason for coming and giving this talk, and for you guys coming and asking good questions and just being around and keeping the community going. So there we go. Perfect. So there is Jason's information. If you want to get in touch with him, that's how you do it. And I do want to let you know about one more thing. So you've got Kubermatic.io, where you can go and run your test is out in the beta phase. We also have something else coming up. So a little bit of a shameless promotion here. We have a very cool event coming up called Container Days. It's going to be in June. So check out the information about it if you're interested. It's a big conference that's got a very party feel. And it's going to be in June in Hamburg, Germany. And you can check out more about it on containerdays.io. And that's pretty much it. This video is going to be up soon. And as always, we will let you know when the next talk is going to be and who will be speaking. So make sure to look at your meetup often. And if you have any requests or any ideas of who you would like to see or what you would like to talk about, we're always open to that. So just send that feedback to us. And thank you so much. And we'll see you next time. Thanks, Jason.
Thanks, guys. I really appreciate you coming out and taking a look. I just posted 2 links in the chat as well. So if you want to take us for a spin and just play around, there's no cost. Right now we're just in a beta phase. So if you can try us out, and if you find anything you really like, let us know. If you find anything you don't like, let us know. And we're happy to hear back from you either via that feedback button, or you can also find us. All of our developers and a lot of our team is in our Slack, so you can sign up for that at slack.kubermatic.io. It's just a Slack in, and we're happy to have you and hear your feedback and help you out with anything that you may have. You can also find me there as k8sOM as well. So thank you again for coming out, and we look forward to seeing you guys again. I think in a few weeks we have some interesting speakers lined up. So take care and have a great evening.
And if you're gonna be at KubeCon in Berlin, look for Jason because he'll be there as well.
Yeah, we're actually bringing our whole team there, so we look forward to seeing you guys. Stop by, grab some stickers, and we'd love to hear some feedback from you and hear about your experiences with Kubernetes. So
perfect, awesome. Thank you so much, guys. I'm gonna close up the chat, and I'll see you next time.